If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip. The question we're working on today is, evaluate the integral from 0 to pi over 2 of sine squared x times cosine squared x dx. Smash that like button and let's get started. So we want to evaluate the integral from 0 to pi over 2 of sine squared x times cosine squared x. And since both of these powers are even, we have to use the half angle rule, which says sine squared x is equal to 1 minus cosine of 2x all over 2. And cosine squared x is equal to 1 plus cosine of 2x over 2. And so we'll sub this into our integral. We'll factor out a 1/4 because each of these terms has a 1/2 in it. We have 1/4 the integral from 0 to pi over 2 of 1 minus cosine of 2x times 1 plus cosine of 2x. We can distribute this out, and we have 1/4 the integral from 0 to pi over 2 of 1 minus cosine squared 2x. And now we're in that same situation. We have cosine raised to an even power. We're going to have to use the half angle rule again. It's common in these types of questions that you may have to use the half angle rule 2 or 3 times before you can get to your final answer. So cosine squared of 2x is equal to 1 plus cosine of 4x over 2. We sub this all in, and we're going to be left with an integral that we could solve. This integral is 1/4 the integral from 0 to pi over 2 of 1 minus 1/2 minus cosine of 4x over 2, which we can group some terms together to get 1/4 the integral from 0 to pi over 2 of 1/2 minus cosine of 4x over 2. Now we can integrate this. We still have the 1/4 on the outside, and we're left with 1/2 x minus sine of 4x over 8. So we really used a little u substitution here, but you could work that out on your own. Evaluated at 0 and pi over 2. And when we plug in the endpoints, we get pi over 16 minus 0, which gives us pi over 16. Make sure to subscribe for more Coffee and Math with Dr. Weselcouch. Don't text and drive. Bye-bye.